Right, discussion point. If you've got a neighbour or something, you can discuss this. Why? Why has mathematics been part of education, a key part of education for millennia, that is, for thousands of years? What's it about mathematics that has been so important? Discuss it with your neighbour. Have a minute or two. If you haven't got a neighbour, find one. What strikes you? What could be some of the answers? Anyone?
I think that the repetitive piece that we see in nature is just the fundamental core of math. So once we can just expand on that. So it's been there since the beginning of time, and then everything just branches out.
So you're connecting nature, mathematics and nature. Yeah, thank you. Yes, Jared?
In education, it's important for the development of logical faculties. In that when I have a child, when I teach them a new form of math, I'm teaching them to kind of run a pathway that's logical. Some of the children, some of them come into the room being able to do it, and others really need to work to be able to think in that manner.
Yes, that comes at a certain age, usually around class 6, that this developing this ability to follow a logical path, yes, but yeah, so at a certain stage that belongs, yes. Yeah, Rick?
I think counting, just counting, has a lot to do with it. You know, whether the counting systems are based on 5 fingers or 10 fingers or something. I mean, you're faced with your biology, you have that the system comes out of that somehow, and you need to keep track of how many children you have, or how many sheep you have, or whatever. Just counting.
Yes, so sort of it has its practical aspect, like in counting sheep and things, and you say that other aspect, it's sort of there's an element that certain numbers are connected with, again, like with nature, ourselves and so on. You know, why do we count in tens? You know? Why don't we count in sevens, or 12s, or 60, like the ancient Sumerians or whatever it is used to count in? Yeah. Okay. Anyone else?
Yeah, I like the blend. It's very vigorous. And so at the beginning of it, when you learn it, you feel strong, you feel powerful when you learn it, and it makes you wake up and invigorates you in a way that everyday life doesn't. It's so organized. But then once you know what's going on, then you feel creative and crazy stuff, quantum mechanics and fractals and just crazy dancing artistry.
Yeah.
And it's two opposites.
Yeah, thank you. Anyone else?
You can do stuff with it.
Yeah, just expand a bit.
It's useful.
It can be useful, yes. Yeah. Sorry, I can't. You've lost your tags, now I forget.
You can reproduce things accurately.
There's there's an accuracy involved with, Mm-hmm. So that's to do kind of with outer tasks. Yeah?
You separate things. And it can be almost an arbitrary separation that you can separate things from. Once you start counting, you put them into groups which are separate from other groups, or you separate them from each other.
Yeah. Or synthesis and analysis, you might say, yes. Yeah. Those aspects. Yes, Rick again?
You can navigate with it. You can learn relationships of one thing to another, and distances and angles and directions.
Yes. You can. It's a way of exploring the world, isn't it? And in a sense, physics is a whole lot of mathematics. You might say, the depth that people have got into physics, all they've got is as far as the mathematics. They don't really understand the mystery of nature, but they've got the mathematics sorted, which is an interesting aspect. Yeah. Anyone else?
You can also see kind of wholeness in relationships of things, simple circles and rectangles and triangles in everything. So it kind of creates a sense of wholeness and unity.
Yeah. But just think of a circle. When you identify a circle, what do? there's a certain principle, there's an idea. A circle is an idea. And you can identify the idea out in the world. And some things are not really circles, but they're circular. So often, one. That's an idea. In mathematics, we're dealing with ideas that can be made visible in the world. What have I got here?
Three pieces of chalk.
3 pieces of chalk. But you see, the 3. Now, as far as this piece of chalk's concerned, it has no relationship to that. I take those away. This is totally unaffected. Where does the 3 come from? And where did the 3 come from? Because if I did this, what have I got? 3 pieces of chalk and a electronic pointer. But I've got 4 objects. So somewhere I have to say, what unifies them? What brings them together? So this is, I think, a little bit what Brett was referring to, that you can put things together. Or, so somewhere, as part of me, I have to identify what is common between these. But again, if I take something else and I say 2 eyes, there's a 2-ness there, but I just can't take this one away and be unaffected by it. You see that somewhere this 2-ness has somewhere where it belongs in what's there. I have 2 ears, 2 nostrils, 2 front teeth, whatever. We have amazing symmetry, 2-ness shown there. But for here, it's the idea from our mind that brings the 2-ness. But anyway, just to go on to some of these other ideas. In all cultures, mathematics and geometry are regarded as preparatory school for initiation or spiritual knowledge. So because it's actually dealing with ideas, that you need to get conversant with the ideas so that we can see with our senses different things, but part of this mathematics, an element, is being able to identify the idea that I can see within it. So it's this element, this deepening the inwardness, that's part of the role of mathematics. It has its useful things that yes, you can't be an accountant without having done some mathematics. You can't do lots of different outer occupations. You need mathematics. But why it was part of education is because you're having to learn to deal with ideas and develop your inner aspect that really create, that human beings are not animals because they're able to think in this, they're able to sort of inwardize and think. It's not that animals can't think, but they do a certain kind of thing. But the inward thinking that belongs to mathematics, I think, is rather limited in the animals. I think the monkeys can count to, I think it's about 3. Is 1, 2, 3, many? Or is it 1, 2, many as their system of counting? I don't know quite what it is. Whereas most of us can get beyond 3. So maths and geometry are based on directed or willed thinking activity. It doesn't mathematics just doesn't come drift through you and flow through you like you actually have to take hold of things and direct your will into your thinking. And whenever the will comes in, you can see this is the spirit, the ego is being involved. And so we talk of this education, education of the will. And we need to sort of explore just, where that's all coming from. Let's have a look. So mathematics, you can direct it to outer sense perceptible things, but largely become independent of these, so that mathematics then starts to work with the realm of ideas. And often what you do, of course, is that you'll start with outer objects, counting outer objects, but you don't need to do that all the time. You don't have to have outer objects in order to count. Thus, numbers and angles are not derived from an external sense perception, although they can naturally be related to it. And true mathematical activity lies in the realm of sense-free thinking. Rudolstein often comes back to this sense-free thinking. You don't have to see an object in order to be able to think. You know, if you close your eyes, which would mean, of course, and box your ears, that you don't stop thinking, just simply go to sleep. Part of the thing is that we are able to sensory think. We don't need to have stimulus of outer objects to make us think. You know, that somewhere we can take in a thought and meditate on it or whatever. This is an element that is, part of the human quality that you are developing in a way through mathematics in school. Though you're not telling the children, we're doing this so that you can meditate a little bit later on. You're not, but you're just going through the activities that engage them. But as teachers, you need to know its deeper connections. A thinking which can rely on itself, not on outer objects, is not only independent of external support, but also renders the person who thinks inwardly independent. Another touching on freedom. What is freedom? This is based the educational task of maths. The Waldorf School math curriculum is correspondingly developed on this foundation. If you want to read more about that, read Georg Glöckler. He writes in this section under projective geometry. It's actually in his wife's book called Health for Life. Education, Health for Life. So he gives that sort of background to education. Now, I won't believe you can read that Chinese proverb, because it's relates that tell me and I'll forget. That's oral learning, just listening. Show me, visual learning, and I may remember. Involve me and I'll understand, kinesthetic. So we're going to go down to the other room and we're going to do some things, some beginning things. Look, we're going to start with some rhythmical counting. So we will do the next sort of activities down in the other room, and we'll come